Welcome back. In this video, you'll understand about RMI. What is RMI and why RMI? You might be wondering, in this web service course, why am I telling about RMI? I want you to understand the concepts in detail, what is happening in the background. So I'll start with RMI and I'll make you to think in a way so that you'll understand about SOAP web services in detail. So let us get started with RMI first. Yep. So what I want to do with RMI, remote method invocation in Java. You might have already worked on RMI or you might be knowing RMI, but just quickly to kick off your thought process, let me start with example. So a simple scenario is there. I have an interface called as stock quote service which has two methods. First method is get price. If I give a symbol, stock symbol, it will give me the price of the stock, and update method is there to update the price of a stock. This is a simple interface. I want to expose an implementation of this interface to remote clients so that a remote Java client will be able to access the methods present in the implementation. So how to achieve these things? So let me just show you by using a diagram. Okay. So to understand diagrammatically, let me just draw it. This is one Java application, assume, and here I have a object, and this is another Java application where a thread is running. A thread on another one JVM, I'll say JVM1, wants to invoke a method on an object inside JVM2. So as this thread and the object are remote to each other, we want to achieve a remote method invocation. So if two objects are on same JVM, they are said to be local to each other. If they are on two different JVMs, they are remote to each other. By using RMI, we will achieve remote method invocation. So how? So if I want remote method invocation to be possible, let us think about the concept. So on the JVM2, I call this JVM2 as a server machine because we have an object on this machine. I'll call this a server and I'll call this application as a client application. So an object on server should be accessed remotely. So to think conceptually how this is possible, what I want is, I want a thread on a server machine to start listening on some port. And on the client side, I want a proxy which is implementing same interface as the remote object. Proxy means what? An object which behaves as if it is a virtual object. That means whatever methods present in this remote object, there are two methods in this object, is it? My stock quote service. So two methods will be available with same signatures in the proxy also. Suppose if on the client side also, if I can get a proxy somehow, what I can do is, on this machine I can call a method on the proxy. This proxy knows how to make a socket connection to this port where a thread is listening on server side. Then if this proxy can send the method invocation details to here, then this thread which is listening on the port can invoke the corresponding method on the remote object. Then the return value can be sent back again using the same connection. That will be the idea, right? So in RMI terminology, the server thread which is listening on a port, we generally call it as skeleton thread, and the proxy on the client side, we call it as stub. So if you want remote method invocation to be possible, you need a client side stub and server side skeleton. So client will always call the methods on the client side stub. Stub will take care of all the networking details like establishing socket communication to skeleton. Stub will send the method invocation details to skeleton. Skeleton thread will invoke the original method on the same JVM. Then the return value will be passed along the same connection. The stub gets the return value and it will return back to your thread. So that's the idea behind remote method invocation conceptually. But to achieve this, we need to write code for stub and skeleton, which is really difficult. So if you can follow some rules given by RMI framework, the stub and skeleton can be automatically generated. What are the rules? So whenever you are writing an interface, firstly, you need to make sure that your interface extends java.rmi.remote. So I modified my interface to extend java.rmi.remote, where I have two methods. Second rule is to make sure that every method in the interface, remote interface, should declare that it throws remote exception. That is the second rule. Then third, whenever you are implementing the remote interface, your class should extend unicast remote object and should implement this remote interface, the interface which is extending remote. So, and here you have to write your implementation, whatever you want for your methods. That is a rule. Then, if you see, the constructor of unicast remote object declares that it throws remote exception. So, if the constructor throws an exception in super class, the first line in the constructor will be called to super. So, shall I put the super in a try catch block? No, right? Super should be the first line inside the constructor, right? So super should be the first line. You should not even surround it with try catch. If superclass constructor is throwing an exception, subclass constructor also should declare that it throws an exception. That's why I'm throwing it. Okay. So this is the implementation. Now once you have the implementation, what you have to do is, this is the interface and this is the implementation. What you have to do is, by using a tool called as RMIC. RMIC is a tool present in JDK bin. By using RMIC dash class path space dot, that means current folder is in class path, give the qualified class name of your implementation. Whenever you say RMIC, automatically stub code will be automatically generated. Let me show you. This is my project. I'll go to the project location. I have already generated it. See, in the bin directory in.co.wetlearn. No, it is not there. So I'll go to this. I'll go to up to here. I'll go to command prompt. I'll go to the directory. Then I would say RMIC dash class path space dot, that means current folder in class path. And what is implementation class name? in.co.wetlearn dot, what is the class name? Implementation class name stock code service IMPL. Let me just generate. If you see here in bin in.co.wetlearn dot, see, a stub.class file is generated. So stub is automatically generated by using RMIC. That's what I told. If you follow these rules, stub code will be automatically generated. Now let me talk about server thread. How the server thread can be started? Let me show you. Here I have a class. I have written a class called a server where I have a main method, and I am creating an object of the remote class. This is an object of remote class. Now if I run this, what will happen? Main thread starts, it will create an object, and this is printed. Then the main thread comes out of main method. I expect the program to terminate, but why is the program not terminating? Still it is running. I'll terminate it now. Why is the program still running? Because if in your Java program, if there is at least one thread which is alive, the JVM will be alive. So what happens is whenever you create an object of this remote class, the first line in the constructor of your class will be called to superclass constructor, which is a constructor of unicast remote object. So this constructor is having the logic to start a skeleton thread. So you need not write the code for starting skeleton thread. The logic is already there inside the unicast remote object. So if we just create an object of this class, automatically skeleton thread will be started. Okay. Then, okay, skeleton thread is started here on server side. If I run the server.java, JVM will start. Object of your remote class is created and also skeleton thread is started. That's on server side. But now the point is, how does the client get the reference of the stub? How to create an object of stub? I don't know. See, this is subclass. I don't have a .java file. I don't know how many constructors are there. I don't know how to create an object of this class. Right? So, if you want a stub object, what is the procedure? Let me tell you. What you need to do is, in JDK bin, there's a program called as RMI registry.exe. You need to start an RMI registry.exe. Once you start RMI registry.exe, there is a program, it will start running a thread, and that thread will be listening on a default port called as 1099 by default. So I can say that RMI registry starts listening on 1099. So what I can do is, see, I have opened a command prompt. Okay, I'll just Ctrl C, clear the screen. Let's say RMI registry. So RMI registry started. This is a way to start RMI registry. RMI registry started listening on 1099. Now in your server, what you can do is, see here what I am doing in server. I am saying naming.bind. First of all, let me say bind. So once I say naming.bind, the logic inside bind method will try to connect it to RMI registry, which is running on same machine. So whenever you are saying naming.bind, the first argument can be like this: RMI : / localhost : 1099 / some string. So once you say RMI naming.bind, this is a URL using which we can connect to RMI registry. By default, if you don't give anything also, the default IP is localhost and the default port is 1099. Suppose if your RMI registry is running on a different IP, then you can give IP colon and the port colon. So right now, as both are running on same machine, as registry is also running on same localhost and 1099, I can say naming.bind. So whenever I say naming.bind, what will happen? A socket connection is established to RMI registry. So this is my server.java. The main thread has established a socket communication to RMI registry. And what is the second argument? I am passing the remote object. What it will try to do is, the server.java, the main thread, it will try to serialize the remote object and send. But whenever you are trying to send a remote object will not be serialized. Automatically a stub object will get serialized and it will go to the registry. Actually, what are we asking? We are asking to bind the remote object with some name. You can assume that in RMI registry, you can assume that it will maintain some map like this, where it is binding the remote object with a name called as SS. So actually on the server side, we are trying to pass the remote object as a second argument. Whenever we are trying to pass a remote object to the RMI registry, automatically its stub will get serialized. So in RMI registry, what is there? Stub object is there. It is bound with name SS. Okay, that is the server side. Once I run this, what happens? Remote object is created. Then the first line inside the constructor is what? Call to super, which is nothing but the constructor of unicast remote object. So there is some logic which will start the skeleton thread. Skeleton thread is started. Then what? In my server.java, I am saying naming.bind. This will connect to RMI registry and it will ask the RMI registry to bind this remote object with this name. But whenever we are trying to send a remote object, its stub will be serialized and sent. So here stub will be serialized and it will be kept in the RMI registry bound with the name SS. Now the client, let me open the client side. The client, what I am doing is here I am saying naming.lookup SS. Whenever I say naming.lookup, the client will connect to RMI registry and ask give me an object bound with name SS. So the RMI registry will serialize the stub and send it. So on the client machine, stub will get deserialized. Now stub is nothing but a proxy which is implementing same interface as your remote object. Your remote class is implementing which interface? This interface. So the stub also will be implementing the same interface. That means whatever methods are present in your remote class, same methods are present. Now my thread will call a method on the stub. See how am I calling on my client? I am calling methods on the stub. Whenever a method on stub is called, the stub knows how to connect to socket, the skeleton port, and then send a method notation. So you need to understand about how the method invocation details are sent in RMI. So actually what the stub will do is it will create a map, and in the map it will create two entries. First one is method name. What is the method name to be invoked? And the method name, let's say it is update. I'm calling update method on the proxy. The method name will be kept as update. And second key is params. Params value will be an array of all the parameters that has to be passed to update. So this map is created, and this map will be serialized by the stub and sent to skeleton. On the skeleton side, it will deserialize the map. After deserializing, it will understand what is the method name to be invoked, update. What are the parameters to be passed? These are the parameters. So the skeleton will use reflection API in Java to invoke the original method. It will get the return value. Return value will be sent back to the stub. That is how remote method invocation happens. Okay. So I want you to clearly understand how is the stub sending method invocation details in RMI. By putting the method invocation details like method name to be invoked, parameters to be passed, etc. inside a map. So this process of sending the method invocation details over a map, we can say that it has marshalling. So client will marshal the method invocation details and send it. On the server side, what is happening? Unmarshalling is happening. Unmarshalling is nothing but extracting the method invocation details from the map, in this case, unmarshalling. So marshalling and unmarshalling in case of RMI is nothing but equal to serialization and deserialization in Java. So marshalling is a generic word given to serialization. Serialization is a term used in Java only, but marshalling is a generic word used by all languages. Similarly, unmarshalling is equivalent to deserialization. Okay, so that's how communication between the client and server will happen in case of RMI. The client is actually working on a proxy. Proxy will take care of all the networking details. But the problem with RMI is the client also have to be a Java application, because the client has to create a serialized map and it has to be sent to the server. The skeleton is expecting a serialized map. That means a C++ client cannot invoke a remote object which is in Java. So RMI will be perfectly okay when client and server both are Java and Java. Okay. So that's about the RMI basics. Hope you understood how RMI works. Try to see this video again if you don't understand, and make sure you understand how RMI works. In my next video, we'll start our discussion on web services. I'll be exposing same stock code service implementation as a web service. I'll use the same terminology of RMI, and I'll convert the application as a web service. See you in next video.